Hi folks. Well, this is the quantitative variables pre-lab, and this is the tidy version. Like last time, I'm working in the RStudio on my own computer, but it's all going to work the same as when you are on RStudio Cloud. And I'm assuming that you were able to download the pre-lab R Markdown document onto your computer and upload it to RStudio Cloud. If you need a reminder about how to do that, you could look at the beginning of the lab video from the categorical variables lab last week, because that was the first thing I did in that lab. So I'm assuming that you have the quantitative variables pre-lab in your pre-labs folder. And I would guess that your RStudio looks something like mine. There's probably a bunch of data in your environment and a bunch of documents open in your document viewer. And so this is a good opportunity to clean some things up. So one thing we can do is in the environment pane, there's a broom icon, and we could click that to clear the objects from our workspace. And it's fine to do this. We have all the code that's necessary to get those data sets back in, and it just helps clean things up around our RStudio. So I'm going to click on that broom icon, and then it says, are you sure you want to remove all objects from the environment? This operation cannot be undone. And yeah, I'm sure I want to do it. I say yes, and now my environment is empty. And I'll also often close a bunch of these files so I don't have so many tabs open in my document viewer. And the way I do that is I go to File, and then either Close All or Close All Except Current, and that'll close everything up. And then you could just click on the quantitative variables pre-lab to get it to open up. And then we're just going to do the same kinds of things that we've done before. Maybe I'll squish the edge of my pane over so that I have a little bit more room. You can always move these around to give yourself more space. So the first thing we're going to do is we're going to load in the same packages as always. So I can remove that comment and type library tidyverse and library infer, and then hit the play button. Load those in. And then we're going to use that same example data set that I'm always using, GSS. That's going to be read underscore CSV, parentheses, and then quotation marks, and then hit tab. Probably you can get into the data folder, and then it's the GSS clean.csv. And then I could press the play button and that data would get loaded in. I might see some messages being printed out, but then I would see my data appear in my environment, and I could click on it and it's going to look the same as ever. So this week we're doing exploratory data analysis for quantitative variables, specifically for one quantitative variable. We'll do 2 variables next week. And quantitative variables are the ones that encode some kind of continuous numeric range. So they're not a categorical variable that just has a couple of categories. There's kind of infinite possibilities for a quantitative variable. Sometimes we talk about integers, which are the whole numbers like 1, 2, 3, 4, 5, 10, 1,000, a million. But you could also have a decimal number like 3.14159, which is the beginning of pi. So those are numeric variables. And I think we've already talked about some variables in my data set that are quantitative, things like number of children, age of respondent, highest year of school completed, etc. So just like last week, we're going to do some exploratory data analysis. This time we're focusing on quantitative variables, but we're still going to do some data visualization and some summary statistics. And we're going to start with the data viz part. So there are a couple common ways to visualize a single quantitative variable. We could do a histogram, we could do a density plot, we could do a box plot. We're going to do all of those types of graphs. So we're going to start by writing some code. We could type ggplot of GSS, and if we just hit the play button on this, we would get just like an empty gray square. It's not very interesting. So we're going to need to use that plus and add on a geometric object, a geom underscore. And we're going to use, to start with, the geom underscore histogram. So inside your geom function, you always need an AES, which tells R the variable in your data set and how to map it to a variable in the plot. So in this case, I've got ggplot of GSS plus a geom underscore histogram. And inside there, I've got an AES where X is the number of hours worked last week. So this is just a visualization of one quantitative variable. So if I run that, I get my plot, and then I also get this warning message. And R says that I should pick a better value with bin width, and also that there's some non-finite values. So this warning about the non-finite values means that there's some missing data for our variable. And if we went and looked at it, let's scroll over. Number of hours worked last week, we can see that there's a lot of missing data, a lot of NAs. NA, 40, 40, 35. Those seem like normal amounts of hours to work in a week. 89 seems like a lot of hours to work in a week, but then again, I'm seeing lots of NAs. So what R is telling us is that there were 967 rows that had NAs. And I only had 2,348 observations, so that's like almost half my data set. So it's possible that we shouldn't actually be doing a plot if we have so much data missing, but that's what it's telling us. But there's kind of nothing we can do about that. There's no way for me to go back and figure out how many hours those people worked, but I can address this part about the bin width. So bin width is another argument to the geom histogram function. So arguments are the things that go inside the parentheses. It's going to go inside the parentheses for the geom histogram, but it's going to go outside the parentheses for the AES. So right outside those parentheses, we're going to have a comma, and then we could put in bin width equal, and then a width for the bin. So if I hit play on this, now I get a much chunkier histogram, and these bins are 15 hours wide. So, you know, the people who worked the smallest number of hours, maybe like 0 to 15 hours, and then 15 to 30, etc. And we can see maybe what we would expect, that there's like this big spike in the middle around 40 hours. Most people, more than 600 people, are working about 40 hours a week. So then what I'd like you to do is try adjusting that bin width and see if you can find one that you think is most appropriate for the data. So you could pause the video and try it out now. Let me try some other values. So instead of 15, I'll change it to 10. Click the play button. I might like that one a little bit more. Maybe I should try making it even smaller. 5 hours. That's looking a little too discrete. If I dropped it down to 1, I think it's going to look really spiky. Although now I could see, like, here's 40 hours, here's 50 hours. I'm guessing this is 60 hours. So we're seeing like spikes at these sort of common round numbers. And then some people, like the person who said they worked 89 hours, they're out here in the tails. So there's no right answer for the bin width. This is one of those places where statistics is more of an art than a science. But I think that 10 hours looks pretty good to me. So now that I've made this histogram, I'd like you to try and make your own histogram of the number of brothers and sisters variable, and try and find an appropriate bin width for that histogram. So I encourage you to pause the video and try it out. Okay, now I'm gonna do it. So I think I'm gonna copy this code, just this much of it. I'm gonna keep the bin width out for right now. And I'm gonna delete this comment, write code here. I'll paste this in. And I'm gonna need one more closing parenthesis to get that to match off. Okay, and then the thing that I need to change is the variable. I'm gonna keep the data set the same, GSS. I'm going to keep my geom the same, geom histogram, but my x variable, instead of number of hours worked last week, is going to be number underscore of underscore brothers underscore and sisters. And if I hit the play button, again, it tells me that there were some NAs, 5 rows where we don't have a value, and then it's also reminding me that it just picked 30 bins, but I should come up with a better bin width. So I could try bin width equal 5. Let's see. That's way too chunky. We do have people who have a lot of brothers and sisters, more than 20 brothers and sisters. Most people have just a few. So maybe 2 would be a better bin width. Or even 1, because these are such small numbers. So then this would show us that, some people have no brothers and sisters. And then this data set is right skewed. It has the long tail to the right. So most people have just a couple brothers and sisters, but there are some people who have many, many brothers and sisters. So now that we've made a histogram, we're going to try and make a density plot instead. And the thing that's going to be different here is the geom. And I'd like you to try to make this. And you can start by just typing out ggplot of GSS plus geom underscore. And then you can just sort of scroll through the geoms and see if you can guess which one that you want. There's a lot of geoms, but I think the one that we want is geom underscore density. And then I could hit tab, and it's going to have the same arguments. It's going to have an AES, x equal, and I could do number of brothers and sisters, and I could hit play. So this is a density plot. So it's kind of a smoothed out version of the histogram, which just kind of shows us a line of the distribution. And then the last kind of plot that I would like us to make is a box plot. And you could probably guess what geom it's going to be, geom box plot. And so the way that box plot works is that it needs a y variable. So before, we've just been doing one variable. We've been saying x equal number of brothers and sisters, or x equal number of hours worked last week. But now we're going to say a y equal. So this is what's different about a box plot, is we could say y is equal to the number of hours worked last week. Hit the play button. So we can see like the median is right around, I would guess this is around 40 hours a week. And then I've got some outliers on the high end and on the low end. And if I wanted to do this for the number of brothers and sisters, I could do that too. The play button. And then you could see, the median is maybe around 3. And then people who had like 10 or 20 siblings, they are outliers. So my dad was one of 13 kids. That means that he would be an outlier. I just have one sibling, so I'm probably down here in the box. So that's how to make a single box plot, but we're going to want to make side-by-side box plots as well for this lab. And so if you want to make side-by-side box plots, then you add back in an x variable. So we leave the y equal to, for example, number of hours worked last week, and then we put a comma and an x equals, still inside that AES. So I could say I want the number of hours worked last week as my box plots, and they're going to be broken down by this categorical variable marital status. And if I hit play, now I'm going to get a plot with a bunch of box plots. And I can see something about the relationship between the number of hours worked last week and the marital status. So I can see that the medians are kind of all the same. But there's definitely something different going on with people who are widowed. That box is really different than the rest of these, which I sort of think might just be random chance over here, but this one is pretty different. People who are widowed seem to be working less than people who are divorced, married, never married, or separated. And I think that makes sense because widowed people are more likely to be older people, and so then they're more likely to also be retired or maybe working part-time. So does this plot make sense? Yes, we would expect widowed people to be working a little less. Just a little note that's related to data. I don't know that you need this for the lab, but it might become relevant when you're working on the data for your particular final project. The x variable for a side-by-side box plot has to be a categorical variable. And if your variable is not categorical, or R doesn't think it is, then you might need to put the as factor function around the name of the variable inside your AES. So right now I added that on and it didn't do anything. So nothing here because we didn't have a problem. But if you had a categorical variable that was binary and it was coded as 0 and 1, R might be thinking of that as a numeric variable, and then it wouldn't work to make a side-by-side box plot of that variable. So that was some material on how to do data visualization for a single quantitative variable or for a quantitative variable broken down by a categorical variable.